React India.
My name is Karan, and today I'm going to present about measuring coverage of design system. Let's start with the introduction first. I am experienced front-end developer with 6+ years of experience, and I'm currently working at a US-based startup called Fabric, which is in e-commerce domain. I have previously worked with Rebel Foods and Razorpay as a front-end developer. So to give you guys a bit of context about what I usually work in my day-to-day life, I'll just briefly explain what our product is. So our main front-end product is a B2B SaaS dashboard where retailers can manage their products, offers, customers, orders, subscriptions, and etc. It's a dashboard built using micro front-end architecture. We have separate product, and each domain team takes care of that particular dashboard. Uh, so for micro front-end, we use single SPA, we use React, TypeScript, and style components. And here is the basic layout that you can see on the right-hand side of the screen. So we were in the journey of migrating from design system 3.0 to design system 4.0. So the major differences between design system 3.0 and 4.0 are like described in the slide. So basically design system 3.0 was built using JavaScript. It was very flexible. It was kind of like due to lot of flexibility, like the domain teams ended up creating a lot of variation and a lot of customization as well. Due to that, like we lacked consistency in our products. Each of our product look if they belong to a different company altogether. In design system 4.0 is like built on top of TypeScript. It's flexible, but it has design constraints with respect to our design language of our company. It's very consistent. It has like tokens, spacing, colors, theme, everything set up that you can use readily in the code base. So while we were in the journey of migrating from Design System 3.0 to Design System 4.0, as a platform team, we wanted to gather some insights or data to take data-driven decisions. So for that, we defined the problem statement as we wanted to identify Design System 3.0 component uses, Design System 4.0 components usage. We all also wanted to measure how many teams or how much native HTML elements the teams were using, and similarly style components as well. We wanted to also create a tree structure of any page or any route, so we can visually see like how our page is built or how our page is composed using different React components. Also, we wanted to highlight any major anti patterns any of the teams were following, so we can course correct and make our code or very clean or very clear. So if you are a very old developer, then if you anytime get assigned any uh, problem, then you tend to Google and see if there any existing solution exists and try to use them directly in your code. But if you're a Gen Z developer, then you might go to ChatGPT and try to search for your answers. I tried both, but every time I got this better luck next time. I struggled for a few days. I asked for help on Twitter as well. I searched like a lot of blogs, videos, and then I hit the jackpot. And then I found this NPM package called React Scanner, which is a beautiful code, which is a wonderful tool you can explore. Basically, it's a NPM package that statically analyzes your code and extracts the React components and its prop usage. So it not just the React components, but also like how many props you are passing to any particular component in your code base as well. So here are some of the options that you can use to control the React scanner configuration. So you can define the root directory. You can define also where you want to crawl from. You can exclude any of the files. You can also define the glob pattern to include or exclude certain files. You can also if you want to only see the components imported from particular library, then you can use imported from as well. And there are a couple of custom options are there, like processors and get prop value. So you can define your own prop value function as well. And processors are uh, are are the functions that processes the raw data and generates the consolidated output for you. It does have few basic defined processor that we are going to talk about in next slides, but you can also create your own custom processor as well. So a few basic processors that React Scanner supports are count components, and another one is count components and props. So it's like self-defined. Count components returns the count of the components, and count component and props returns the uh, count of the component as well as the props count as well, as you can see in this both of these screenshots. And the default processor is a raw report. Basically, a raw report will give you all the instances information, each and every information about any particular instance. It will give you the props information, import information, everything you can think of. So how does React Scanner work? So basically, it works in a way that like it first reads your file, and then it parses your code into AST. AST is like a abstract syntax tree. It's a tree representation of your code. Then it traverses the AST and then gathers the information like component usage, component name, prop information, import information, everything. And then based on the processor that you inputted or passed in the configuration, it will process your raw data and then it will return the JSON format. It can also write to any file that you define in the config as well. So let's talk about AST. So I'm no expert in AST. This is my first encounter with AST as well. So AST is like a tree representation of your program code. I have taken a very basic uh, example. You can see here that there are a couple of uh, variable declarations and one function declaration here as well. So that is represented here in the tree in the similar fashion as well. You can see here the variable declared has two nodes a and 42. Similarly, this one has p and 5. And this function block has like block statement and a return statement that we have here, and it has like plus operator that are have two things a and d. If you want to learn more about the AST, then I do strongly recommend checking out AST Explorer. It can generate AST for any of the programming language, any of the code that you paste into the uh, input, and it will generate the AST for you automatically. You can export that as well. You can do a lot of stuff on AST Explorer. Do check out. So let's see a React Scanner in action. So after using the React Scanner, we were able to generate a few data points, and we were able to chart that data like onto our dashboards. So here is the simple dashboard screen that we were able to create using React Scanners data. Here you can see on the pie chart we are indicating DS3 to DS4 migration status. So it is the ratio of DS4 versus DS3 component usage in this particular Copilot MFA applications. And this usage is further drilled down to particular component. So here like tooltip component used 10 times, and similarly here in DS4 this component is used like a box component used 40 times in admin application. And I thought Hamjeet guy I have done it, but that was not the case because we had some points that we still needed to figure out that were not supported in the React scanner. So few of them, let's go one by one. If you want to uh, build your custom solutions, then first thing you generally do is fork the repo. So we have forked the React Scanner repo in our code base. We now maintain a React Scanner version in internally. The reason behind is that React Scanner is not actively maintained anymore, and like there are no major version released in the past 2 years. So for identifying native HTML elements, we haven't had to make like a lot of efforts. We just needed to check two conditions in our React components. First condition is to check for like if your React element is lowercase and it shouldn't contain any dots. It indicates like subcomponents. So if these two conditions are met, then we are sure that this is a native HTML component. After using this logic, we were able to identify the native HTML elements usage in our dashboard, in our application, and we were able to show that in our dashboard, as you can see in the screen. Style components. So if you have used style components, you may be familiar with this tag template literal syntax. It's basically a syntax where you declare your styles in a escape, like this uh, in this literal syntax, string literal syntax basically. So here you can see you can define the style components in two ways, using dot notation style dot button, or you can use a function call as well. So identifying the style components was not available in the React scanner. For that, we needed to write a custom script or a custom code. So here is the sample code that I wrote to identify if the tag template literal expression is a style component or any other simple style simple string declaration. So here you can see I'm checking for the tag template expression, and then I'm checking if it's a styled object or not. And I'm collecting not just the where it's styled from, I'm also collecting the raw CSS as well. So I'll show you like how I'm using that raw CSS to identify anti-patterns in the code. So anti-patterns are a term that describes like how you should not be solving recurring problems in your code. In the case of design systems adoption, there are few anti-patterns that you may have noticed in your organization as well, like using hard-coded color instead of using a design system token, using like different HTML elements like anchor input button instead of using it from the design system. So here you can see like after all those information that we gathered, we were able to show this style components usage on this HTML elements component, and we were able to give the suggestions to the domain team as well. Last but not the least, and very interesting problem that I worked on was the creating a tree structure of any route or any page. So the idea was to like create a tree structure of any route or a page, so you can visually see how your components are like combined or used with other components, or like how the composable components are used. So here you can see we have a simple user management screen here. We have like few inputs that you can use to create users, and we have a listing table where each row has a like a role selector drop down where you can change the role of the user. So after running this query on this particular route, we were able to see that this is consisted of like button, 2 3 snack bar, one user form. User form is basically a React component which has like internally like composed of multiple components. So here you can see in the dark nodes, these are like like uh, uh, that can be like that are built on top of other components. So here if I click on user form, you can see here like it's built of input icon button and everything. So by generating this graph, we were like visually able to see how this form is made of, like what all components are getting used in this route, and we are also able to see few anti-patterns as well. Here you can see that we are using three like snack bars in single page. We shouldn't be using that, right? Because we should be using only one single bar with different props or with different arguments. So that is the bone version of the tree structure, but we plan to add many more functionalities to this tree structure. So yeah, that was my little project about measuring coverage of design system. To summarize this whole talk, what we were able to achieve was that first thing we were able to achieve was that it gave us the overall idea of how our design system is getting consumed, like how our old system was getting consumed, and in comparison how our new system is getting confused. Also, while using the data from we were able to take better decisions while like doing a migration of certain elements, like what all props to like deprecate and what all props we should continue supporting, or we should have like uh, a backward compatibility as well. And also using this tool we were able to highlight the anti patterns and improve the code quality in turn. So yeah, here are the references if you want to learn more about this topic. Do check out them. I'm on Twitter, LinkedIn. Please, if you want to connect, we can connect there as well. So yeah, that's it. Thank you, guys.
Thank you so much, Karan, for such an enlightening talk. And it was truly inspiring. And like, still, I work in Zomato, so I currently can surely relate to whatever you taught. So I am working towards styling my design systems in Zomato as well. So yeah, it was a good session. And like I can see some of the questions in the chat as well. So would you like to take this up?
Sure, sure. First, I would like to thank you all for organizing this awesome event and giving me the chance. I would also like to apologize. Like the my talk was not full width as I was traveling. I am currently stuck in my hotel room with the bad internet. But yeah, thank you very
And
much.
then that was truly awesome, and yeah, it was good. So the one question that I see is how do we test components like video, audio tags, as they might not run on the headless environment. So that is a question.
So basically, whatever we are doing, like running the scans, we are not doing any headless browser. We are doing it at code level. So if you have written any single video tag in your code base, we will be able to identify. The advantages of using any static code analyzer is like you can get the data at like when you are merging the MR before you can run that in any headless environment or you deploy it anywhere. So that's the advantage of React Scanner.
Got it. Thank you so much, Karan, for your taking the time for the talk, and it was truly enlightening. And yeah, thank you so much.
Thank you everyone.